In this episode, we are going to talk about the harmonic mean. This is one aspect of the mean we are also going to treat in this episode. It is very simple to find the harmonic mean. So let's begin with giving random variables x1, x2 up to xn. The formula to find the harmonic mean is given us, so harmonic mean can be written as HM. It is giving us n, which represent the number of occurrences on 1 on x1 plus 1 on x2 plus up to 1 on xn. So this is the harmonic mean formula for random discrete variables. Are we okay? So once we know the number of occurrences, say if the x they are 7, then we are going to have 7 number of what? X's. So we are going to divide that with 1 over each of the appearance. So the last appearance. Are we okay? So say we have 2, 5, 8, 2, 10. The harmonic mean is going to be, this is 1, 2, 3, 4, 5. So our n is equal to 5. So that is going to be 5 on 1 on 2 plus 1 on 5 plus 1 on 8 plus 1 on 2 plus 1 on 10. This should give us the harmonic mean for random discrete variables. Are we okay? So in this episode, let's add the group and the discrete variables. So this formula is used for random discrete variables. If we have a group data, then the harmonic mean is going to be giving us summation of the f, which is the frequency, on summation from I equal to 1 to n of the frequency over xi. This is also a simple formula for group data. Are we okay? So we use this for ungrouped data, we use this for group data. Let's solve examples under each of them. You don't have to take much time in understanding all this mean. Are you okay? Once you get your formula, you could do anything to manipulate them. Let's look at an example. Now find the harmonic mean of the following. We have 4, 7, 9, 6, 14, 21, and 5. You can pause the video and find the harmonic mean. So this is our data. 4, 7, 9, 6, 14, 21, and 5. So our n, number of appearances, they are 7. Are we okay? And our harmonic mean for random variables is n on 1 on x1 plus 1 on x2 up to 1 on the xn. So let's put in the values. So this is 7 on 1 on 4 plus 1 on 7 plus 1 on 9 plus 1 on 6, 1 on 14 plus 1 on 21 plus 1 on 5. So once you punch this, you are going to have 7 on 0.9896, which is equal to 7.073 as your harmonic mean. Are you okay? So with this formula, you could use it to solve for many examples. You can try them out yourself. Let's look at an example which also involves the group data. How do we use that? So once we solve one example under each, you are good to apply it in any aspect. So example 2, calculate the harmonic mean. We have a table with our data. So from 0 to 10 marks, we have 2 7, 13, 5, and 3, and we are to find the harmonic mean. In situations like this, if you want to know how to construct your table, your parameters, first find the formula that relates with the question. So this is group data, and harmonic mean for group data is going to be summation of f, which is the frequency, on summation from I starting from 1 up to n f on x, or summation of the f on x. Are we okay? So this is the formula. So meaning from the table we will need x, which in group data is going to be the midpoint, which is x. After getting our x, we are going to also need another parameter, which is the frequency on the x, and that will let us have our harmonic mean. Are we okay? So now the midpoint is the average of the class. So this is going to be 10 plus 0 on 2, and that is going to give us a midpoint of 5. This is going to give us 15, and we are also going to have this as 25. We are also going to have the midpoint here, 35. The same thing happening here to be 45. So this is f on x, the frequency. So 2 divided by 5, that is 0.4. We also have 7 on 15, that is 0.4667. We have 13 on 25, that is 0.52. 5 on 35, that is going to be 0.1429. And 3 on 45, that is going to give us 0.1, 0.0667. So after everything, we are going to find summation of f on x. That is going to give us 1.5963. And we also have summation of f here to be 30. So straight away we can calculate our harmonic mean, which is summation of f, and we have the summation of f to be 30. Summation of f on x, we also have it as 1.5963, and this is also going to give us a value of 18.83. So this is the harmonic mean. So as I said, always get to know your formula. Once you know your formula, it is very easy to tackle any of them. So now, by the end of this episode, you should know the difference between harmonic mean. You should have known the difference between arithmetic, geometric mean. They have a relation. Always, we are going to see that the arithmetic mean, this is harmonic mean, this is geometric mean, and this is arithmetic mean. So we are always going to see that this is less than or equal to this. This one is also less than or equal to this. So always when you have the same data, arithmetic mean is going to be the largest, followed by geometric mean, and harmonic mean is always going to be the smallest among them. Thank you for watching the episode. These are all the basics for statistics. In the next episode, we are going to dive deep into variance and standard deviation and the actual work. Please subscribe to the channel, like the videos, and stay tuned.